Hi there, everyone. Your first lab, you're going to do measurement and errors. And in this lab, you're going to learn how to use a vernier caliper and how to do data analysis and error propagation. Regarding how to use a vernier caliper, what you're going to do is that you're going to watch a video, a short video. In that video is going to be demonstrating how to use a vernier caliper and how to do the reading on the vernier caliper. Here, I'm just going to show you the main things, when you have a reading, how to read it off the vernier caliper. Now, there are several things you need to know. One is the terminology, least count. That means the smallest value that can be read directly from the vernier caliper, vernier scale, right? And so let's see. So take for example, let's say this is a vernier caliper. It comes with the two scales. One is the main scale, which is in the upper one, and that's in centimeters. And the lower one is the vernier scale. That is in one of the smallest is one of the 20th, millimeters. So you can see that this provides a better precision than a ruler. So when you close it, the zero on the main scale and the zero on the vernier scale, they coincide with each other. So let's say you use it to take some measurement, and what you found is that when you open it up, and this is basically what you got here. So how do you read off from this? Okay, so you can see that. So the first thing you need to do is identify where the zero on the vernier scale is in relation to the scale on the main scale. So for example, the zero here on the vernier scale is to the right of the 11th mark on the main scale. So remember, this is in centimeters, on the main scale. So this is 1 centimeters and this is 1.1 centimeters. We need to convert that to millimeters because on the vernier scale, the smallest is in millimeters. So when you look at the zero lies between 1.1 centimeters and 1.2 centimeters. So before the decimal point, it is when converted, after you convert it to millimeters, you would do this. You will use 1.1 centimeters multiplied by 10 to convert it to millimeters. So that is the reading, and then adding to that, we want to also know what's on the vernier scale. So on the vernier scale, you want to look for the line on the vernier scale that coincide with the main scale and become a straight line. So when you run through this, all the marks on the vernier scale they do not align with the marks on the main scale, except for the one that is between 7 and 8. So how many divisions are there on the vernier scale? If you look at this, so there's 0, and you have the 1, 2, 3, 4, and so altogether between 7 and 5, that's 15 division. 15 division multiplied by 1/20, because each division has 1/20 distance. So the reading will be 1.1 centimeters times 10, that's from the main scale, and then plus 15 times 1/20, which is 15/20. So altogether, that will become 11.75 millimeters. So this is how you're going to read off on the vernier scale. Look at where the zero on the vernier scale is in relation to the marks on the main scale. In this case, that is 1.1 centimeters. So you multiply that by 10, and then you want to look for where is the mark that aligned with the mark on the main scale. So in this case, that is between 7 and 8 on the vernier scale. That this line aligned with the mark on the main scale the best. So that will be our choice. So this is actually 15 division and multiplied by 1/20. So altogether, that's 11.75 millimeters. So the vernier scale actually is designed that you can just read off without multiplying by 1/20. If you have If you look at this, that is between 7 and 8. So you have 7 and you have the 8. So in between 7 and 8, that would just be 7, 5. So whatever that's from the Vernier scale is after the decimal points. So it's 0.75, and the numbers before the decimal point is from the main scale. So this is 0 here. So the 0 is between 1.1 centimeters and 1.2 centimeters. So it is 1.1 by multiplied by 10. So that together is 11. So you have the 11.75, and the unit is millimeters. Okay, so that's basically in practice, how you read all from the Vernier scale. Just identify the 0, identify which one that aligns the best with the main scale. Okay, all right. So that is that how to use the Vernier scale, and then let's look at measurements. Now we know that when you have a measurement, usually you don't just measure it once. So let's say you could measure the same things, like a few times, and we know that each time when you do the measurement, you're going to have the subject to error because of precision and things like that. So in that case, how we take that into account about the errors. So this is the second focus of this experiment. So let's say when you take a measurement, and we know that when you take a measurement, you have what we call the single measurement. So when you have a single measurement, that's you measure we call that x, and then it has the error delta x. So you would usually express the uncertainty, the measurement as x plus or minus delta x, and delta x, of course, indicates the uncertainty, the range where the measurement could be. Okay, so the measurement could be any value between x minus delta x and x plus delta x. So delta x in this context is called the absolute error. So absolute error, of course, you will have the same unit as your measurements. All right, and then if we divide delta x by x, this term, we call that fractional or relative error. Okay, so usually we just call that its fraction. So what is uncertainty? When we express that in terms of relative error, then this is how you would do it. The absolute error divided by the measurement is the absolute relative error. And then when you use that relative error, multiply that by 100%, that is called percent error. And this is the one that you're familiar with. Let's say this measurement is subject to 5% percent error. So this is how you calculate percent error. Relative error multiplied by 100%. Okay. So your measurement can be represented. If that's a measurement, there's always uncertainty associated with that. So you would express your measurement as x plus or minus delta x, or x plus minus delta x over. So this term is actually percent error. Okay, and then so what about when you take the measurement not just one time? Let's say you take a measurement 100 times. So in that case, and each time, each measurement has its own error, and then so when you measure it 100 times, you're going to have 100 different errors, and each one is each measurement has its own associated error. So in that case, how do we account for the error associated with this the batch of measurements? So this statistically, this is how we're going to do it. So let's say you measured, you take a measurement, you measure it 100 times. How are we going to find the value that represent the 100 trials? So what we are going to do is that we find the average value of the measurements. So the average value of the measurement, of course, is called the mean value, which we all know how to do it. You just sum up all the trials and divide it by the number of trials. That gives you the mean value. Okay. What about error? How do we express the error? So to calculate error associated with this 100 measurements, recognizing that each measurement has its own error, we need to have a way to account for the error from that 100 measurements. So the first thing to do is to calculate a standard deviation. a standard deviation, which Excel has this built-in function. The standard deviation is basically, if you just look at this expression, that is the mean value minus each individual measurement, and you square it, and you sum up all the terms and divide it by the number of trials minus 1. So this basically tells you, standard deviation basically tells you, how far away is each individual measurement in comparison to the mean value, the variations. And then to calculate standard error, you will use this expression. So the standard error is the standard deviation divided by the square root of number of trials. So if you measure 100 times, then you do this, that will give, then you will get the standard error. Okay. What about relative error? To do the relative error, you would do this. The relative error would be, so I'm going to write this, and then the relative error, let me see, the relative error would be the standard error, which is this symbol, the standard error, and then divided by the mean value. Okay, so this is what we call the relative error. This is standard error. This is relative error, which is the standard error divided by the mean value. Okay, so this is what we call so this is basically, when you take the measurement 100 times, 1,000 times, how are you going to account for the error from this batch of measurements? Then this is the statistically, this is how you're going to do it. So so today, what you're going to do is that you're given a iron bar, and the iron bar comes with the width, the length, and height. So you're going to use a vernier caliper to measure each dimension 5 times, and then you're going to find out, you're going to figure out what is the error associated with your measurement. In addition to that, you're going to find the volume, and we all know that the volume will just be the width times the length times height, right? Use the average value, and you're going to find the error associated with the volume. Now remember, when you use the vernier caliper to measure width, length, and height, these are directly measured quantity, so you can just use the procedure that we just described to calculate the error associated with each quantity, like width, length, and height. What about volume? Volume is not directly measured. We calculate volume is actually what we call the derived quantity, because you use this, you multiply W, L, and H together. So volume is not directly measured, but then we do know that it comes with the error, because each quantity has an error associated with that. So to account for the error associated with the volume, which is not directly measured, there's what we call the error propagation. So what exactly is error propagation? Error propagation is basically tells you that when you have a quantity, so let's go to the appendix. So what is error propagation? Error propagation is tells you that if you had two quantities, let's say in this case A and B, so you measure A, you measure B, and then you want to find a third quantity which is not directly measured, but is actually through the mathematical operation that you got this quantity. What is the error associated with this? So when you look at this table, you'll find that really depends on, even though you measure A and B, but the error, to calculate the error associated with Z, which is the quantity not directly measured, it really depends on how you, it really depends on how you, what kind of math that you do. For example, when you add them or when you subtract them, what is the error associated with Z? Now, in this case, you can calculate absolute error delta Z, and which is a square root of the sum of the squares. So delta A is the absolute error of A, delta B is absolute error of B. So to calculate absolute error of Z, this is the equation that you use to calculate delta Z, okay? But then when you look at the this expression, when you multiply them together, then to account for the relative error or the absolute error is different. If we just look at this and that, they are apparently quite different. So for the derived quantity, how to calculate the error associated with the derived quantity really depends on what kind of math that you use, mathematical operation that you use. So for a multiplied by b or a minus a divided by b, you can see that they follow the same format. So you're going to calculate the relative error, and then the relative error of z can be calculated using this expression. Delta A over A is the relative error of A. Delta B over B is the relative error of B. Okay. So when we apply to the volume, in this case, the volume, so let's say your V is equal to the mean value of length times the mean value of height and times the mean value of width. And each one has its own error. So in this case, you can calculate, let me just write here, you'll have V over V, the relative error of volume, will just be the square root of delta L over L square, and then plus delta H over H square, and then plus delta W over W, and then square. Okay, so you can see that to calculate the error, the relative error of volume, you would use this. This is the square root of the sum of the squares of the relative errors of each terms. Okay, and so you can see that for other, let's say when you have power, when you do the power, when you do the exponents, or when you do the trigonometry, and these are the equations to use when you encounter the error. Okay, so that's basically how you would do it. So for today, what you're going to do is, as I mentioned, you're given an iron bar, and you're going to use a vernier caliper to measure 5 times each dimension, and you're going to find the average value of each quantity. You're going to find the standard deviation. You're going to find the standard error. You're going to find the relative error. Okay, and then in addition to that, you're going to find out what is the volume, what is the relative error of the volume, what is the percent error of the volume, and what is the absolute value of the volume. And you want to organize your data very similar to this. And in fact, when you organize your data that's similar to this table, if you just read through the instruction, it's going to tell you how to find the relative error of volume, for example. Okay, so that's basically what you're going to do. And for sample calculation, I do want you to write down the equation, write down the numbers that you plug in, and the end results. Okay, and the equations, you have the equations here, you have the equations there, and then you just have to use that. Do not just say that you're using cell number B2 to B6 to calculate the average. Your B2 and to B6 may not be the same as mine, so that is not it's not universal. You need to be specific. So the thing that is very specific will be you write down, you have the equation, and then you have the numbers, and then you have your results. Okay. So take for example the relative error when you want to do the simple calculation. This is the equation you should have, and then the next line will be the numbers that you plug in on the right hand side, and the third line will be the results. Okay. And the other thing is that, let me see, what is the other thing? So you measure the width, length, and height 5 times. You only, for sample calculation, you can just pick width, or you can just pick one of the quantity. You don't have to repeat it you don't have to have sample calculation. Once you, let's say you do sample calculation for length, then you don't have to show it for width and height. You just need to show me one equation, one sample calculation, so I know what you did. Okay, so that's basically for today's experiment. You need to learn how to use a vernier caliper. You need to learn how to read off a vernier caliper. You need to know how to do data analysis, you need to learn how to use Excel, because we're going to use Excel to process the data. So I do not want you to punch into your calculator to do to find out this value. You want to use Excel to do that. Now, what I'm going to do is that, hold on, let me see. Okay, so I'm going to share another one. So before I show you how to use Excel, so the vernier caliper, how to use the vernier caliper? Once you go to your Canvas folder, you click on module, and then once you click on module, there's a full subfolder called resources, and then here's the one that that is how to use the vernier caliper. You definitely want to watch that, because the quiz you're going to be quizzed on this on this, and also the data analysis, the error propagation. Okay, so make sure that you watch, you read the, make sure that you read this. You read this first, and then you watch the video, and then how to use the vernier caliper video, and also of course you watch this video, and then take the quiz by Tuesday 11 p.m. Your data analysis is due Thursday 11 p.m. and your lab report is due Sunday 11 p.m. Now let me show you how to use Excel to do the calculations. So let's say you have this data. So you punch in, so key in the data to the Excel, and you have the length, width, and height. How do you calculate average? So to do any calculation, you click on this empty cell, okay? And then you hit equals. Whenever you want to do mathematical calculation, you click on empty cell, you hit equals, and then you find, because average is a built-in function of Excel. So on this tab, there's a drop-down menu. So click on that and find the one that says average, choose that, okay? And then click on this icon, and then you select the data that you want to do the average, and you hit this icon again, and you hit OK, and it shows you the average, okay? So when you do this for length, it shows you how to do the average, and then you can do the same thing for width and height, but there's an easier way to do it. That is, you click on the cell, and you move your mouse until you see a solid cross, and you drag it along. When you do that, it actually calculates the value automatically for you. So you don't have to repeat the average again, okay? Now, let me show you how to do the standard deviation. Standard deviation, again, is a built-in function. So click on the empty cell, hit equals, and then from this drop-down menu, find standard deviation. So choose that, and then click on this icon. And then you choose the one from this to all the data. Do not include the average value, okay? Because the average is not the measurement. And you hit this icon again, and you hit OK. So this is your standard deviation. And then you move your mouse, dragging across, that calculate that for you. Standard error. How do we calculate standard error? Standard error is the standard deviation divided by the square root of the number of trials. So click on this empty cell, hit equals, and then click on this cell. This is the standard deviation divided by the square root, SQRT, and then the number of trials, you measure it 5 times, so that'll be 5, and then another parenthesis to close the parenthesis, and then hit enters, and then you got that. Okay, so this is how you calculate standard error. So click on that, move your mouse, drag it across, and you got that. Relative error. How do we calculate relative error? Remember, relative error is the standard error divided by the average value. So click on the cell, hit equals, you click on standard error, and then divided by the average value, and then hit enter, and then just drag it along. So you can see that once you know how to use Excel, doing the calculation becomes very easy because you can do, this is the only 5 measurements. You could be dealing with hundreds of data. There's no way you're going to key in the data to your calculator and ensure that you actually keying everything correctly. So this will be a better way to do it, because once you, you just select the data and you do the calculation, and then you can repeat the calculation, in less than a second, to be honest, right? All right, so how do we calculate volume? Click on the empty cell and then hit equals, and then volume, we're going to use the average value of length, width, and height to calculate volume. So we're going to do this, select the average value, and then multiply is, we use star, and then click on this, and then star, and then click on this, and then hit enters. That gives the volume. So this is the volume of the iron bar. How do we calculate relative error? Remember, volume is not a directly measured quantity. We have to use error propagation. For error propagation, that will be, you can actually follow the steps in the analysis, step 5 in the analysis in the activity 1. It shows you how to do that. Click on the empty cell, hit equals, and remember, it's actually the square root of sum of the squares. So square root of the sum of the square, that will be SQRT, parentheses, and then relative error of this square. So square, you can use caret and 2, and then plus this square, and then plus this square, and then close the parentheses, and then hit enters. So this is your relative error. How do we calculate the percent error? To calculate percent error, that would be click on the empty cell, hit equals, and this is calculated by relative error multiplied by 100. That gives you the percent error. So you can see that the percent of this activity is actually 1.08%. Absolute error will be calculated by hitting equals. That will be the relative error multiplied by the average value, and so of this value. So this is the absolute error. So you can see that for the iron bar, what we got is that the volume has a value of 268.91 millimeter cube plus or minus 2.92 millimeter cube. So this is expressed in absolute error. And to express your measurement in percent error, your result in percent error, that will be the volume plus or minus 1.08%. Okay, so that's basically what you're going to do. As I mentioned, for sample calculation, you can just pick one of the quantities to show. You don't have to show every like width, length, and height. And then you have to show average, how you calculate average, standard deviation, standard error, relative error. And in addition to that, you need to show how to calculate how you calculate volume, how you calculate relative error for volume, percent error, absolute error for volume. Okay. And the other thing is that when you do the sample calculation, you do not show me you're doing from B2 to B6 for the average. I want you to actually include the equation. So for example, the standard error, instead of saying B8, you would say that it is a standard deviation, which is sigma, over the square root of n. Okay, n is the number 12, and then so you use the n instead of 5, and then in the next slide you use 5. Okay, alrighty. So that's basically what you're going to do. So remember, your quiz is due Tuesday 11 p.m. If you have any question, come to my office hours, or go to the TA's lab session. The Q&A session, and they can help you with any questions that you have. Okay.